All right, good evening. It's good to be back. It is a new year, at least for us here in the U.S. I'm not sure I can say that that year started off any better than the old one ended.
I believe
Uh,
my wife put it really nicely. 2021 looked at 2020 and said, "Hold my beer."
I'm getting an echo from you for some reason. Uh, there was always something we end up having to tweak when we're. Uh,
Try that again. It might have been my desktop audio coming through the through OBS Ninja.
I still, yes, I'm still. I think
Okay.
I've got you. Sound very tinny.
I don't know why that would be. That one's.
That sounds a little better.
Hmm? So I can bring the keep
No,
bringing the mic.
there's an echo somewhere. Am I doing that? Yeah, I can. Sorry, we're gonna work this out here just for a second, and then we'll be right back with you. Hold on a second. Yeah, I think so. No, wait, no, up. Now I lost your feed. I'm hearing
Okay,
you.
never mind. How's that?
Try again.
Are we there?
Yeah, I think
Are we
so.
there yet?
Yeah, I'm still here. It sounds a little weird, but
I don't. I can't tell you why.
I mean, I could hear you when
Uh,
when you muted your OBS Ninja stream. So there's something. So are you sure you muted on Discord?
yeah. Yep.
Now you are. Yeah, now you sound good.
I
Yeah,
don't know what
yeah,
I did.
yeah. You're good. You're good.
I don't know what I did.
You're
Huh.
good. I think it was just
That's a fun
me.
one.
All right, let's try this
Good.
again. Yes, yes. Hold my beer.
uh,
So for those of you, so first of all, let me say that I hope everyone who's joining us here is has a wonderful morning, day, afternoon, evening, night. Wherever you are on the globe or whatever your sleep schedule may be. Um, yeah. So for those of you that maybe maybe either watching us live here or on the VODs who are not in the U.S. We had, let's just say, a bit of a scare yesterday. So we're all still a little bit shaken by the fact that we uh, sort of
that what
watched a coup,
extremists attempted to take? Yeah,
watched
attempted a coup.
watched a coup attempt unfold on national television. So yeah, that was a little unsettling. All right, so let's move on from that to happier topics. Not so, not entirely. I wish I was done with it category. YouTube is getting better. I still need to pop some more links on the webpage, but I just did not take into account how long YouTube takes to process videos, especially if they're over a few minutes long. And so I've got a whole bunch of videos in the queue that are sitting there processing, getting ready to be published. So within another day or two, I think all the back episodes will be up on YouTube, and I'll put something out on Twitter, and I'll make sure that all the links are on the website. Right. So with that, we're going to talk a bit about well, the what Derek Slip and I were talking about really had to do with, we're building the local streamer tool. We've talked sort of about the structure of web applications and those kinds of things. And so one of the things that we wanted to talk about today was how do you actually when you're building these applications, how do you troubleshoot what you're writing, and how do you troubleshoot if something is finished but it's not working, or if you're working on it and if you're putting the feature and it's not working? And of course, in one of the earlier streams, we looked at the developer console in the browser, and that's clearly one way of doing it. And so I think so. I'm going to start by talking a little bit about generically what troubleshooting, debugging. Do you know where the term bug came from in software
They
development?
say that, so it's obviously it's potentially apocryphal, but Ada Lovelace found a moth in one of those giant room-sized computers of the 50s or 60s.
Ah, and
That's,
and
I mean,
and
that's
uh,
who
and
knows,
yeah,
but
so that
that's
may
the
be
term
it.
bug. A bug
Um,
was found that was causing problems with one of the original computers,
right.
found by one of the parents of modern software or modern computing, Ada Lovelace. But
That's as good a story as any.
I,
So,
I like it. I go with it.
so I started in my career as a physicist and software developer on software that really just ran on a client on a client platform, maybe a server platform, depending on your point of view. So the kind of the original idea of debugging, of finding a problem that was keeping a software from working correctly, sort of involved basically getting visibility into what the program was doing, uh, and what its state is, what are the values and stored in variables and those kinds of things. And there are various ways of doing that, and I'll more towards the end of the stream, I'll let PX Lips I think take over and sort of talk about how that actually works, especially in modern
Hopefully.
applications, because a lot of the stuff that I used to do just aren't all that applicable. But just sort of as a I guess as a point of reference, a sort of historical point of reference, um, a lot of the software I started building really didn't have any, the platforms I was working on really didn't have any advanced debugging capability, and the ones that they had were almost not terribly usable. So a lot of times you basically, if you had a bunch of code, you would in effect insert some extra code that would dump some of the state of your software package at that point out into a log file, so you could figure out what was going on. So relatively simple stuff, but that's still today something that I certainly do. And when I write scripts and those kinds of things, I still use that approach a lot. The more traditional debugger was intended to sort of do that in a more automated way and giving you sort of a two-way interaction between a separate debugging program and your software. So these things are super useful, and my colleagues in the computer science arena are very much that's very much what they use a lot of times to deal with with trying to find problems with software. So this is one aspect. Now, of course, we double this problem if we have a client-server application, right? And so obviously, most of what we want to do is focus this on the kinds of issues that we're dealing with when we have a modern distributed web application. We talked about that a lot on stream. We have a front end, maybe JavaScript, something running in a browser, maybe an Electron app. I have the back end, the server, and so I could certainly technically do the same thing here if I have access to the server. In the case of LST, some of the back end will be Twitch or Streamlabs or whatever it is, and so will not be under our control. So there's nothing we can do to see what's going on here. So I guess the point that I want to make, and that is sort of relevant to the main part of what I want to discuss today, is the fact that if I have a client server application, then there's a network, right? We have the client and server talking to each other, and not surprisingly, we talked about Wireshark a couple of episodes back. So one debugging capability I have is to look at the actual information that runs between the client and the server using Wireshark. Right? Now, in many cases, you want to do all of these things. In some cases, especially if I don't have access to the server, they clearly if there's the return. Whoops. Okay. I guess you can. You can't have arrows that go the other way. That's all right. That's all right. We can do it. We can do it. We have the technology. What are you? Yeah, there we go. I'll use that guy. All right. So if the server is communicating back to the client, there's nothing I can see on the server. I can maybe have the client tell me what it received, but clearly, especially if I can't see half of the code, look into half of the code, doing this is useful. It goes beyond that, and this is a little bit of a bias on my end. I'm a networking person, and I used to write a lot of standalone code, non-network code. So I have some approaches on how I would handle for those kinds of things, debugging, and they're still applicable, as I said, for things like scripting. If I write a Python script, that's still, what I was doing back then is still pretty useful. But of course, most of my career I've spent as a network person. I worry about how to get stuff to work that is very heavily there we go. That's very heavily involved with transmitting stuff on the network. And so, one of the things I've come to realize is that sometimes you have to work under the assumption that the client, the stuff you see here in the debugger. I grab this guy. So, this stuff here, where I'm looking at the state of what the client is doing, that of course depends on, getting accurate information via the debugger or via some sort of diagnostic statements out of the client. And one thing I've learned, especially if the code is not all yours, say, the server is doing stuff that you didn't do yourself, software will lie to you. So by way of an example, and so because software will lie to you sometimes, seeing what's actually happening on the wire, it would be useful, right? And so a good example of this is the software that I work with professionally as part of a research group at our university. It's the software that NASA is going to use. They've started to use and will deploy much more widely going forward for deep space communications. It's sort of an internet-like set of capabilities, but designed for all the different things that happen if you try to talk to Mars or the Moon or whatever. And even though it's not technically necessary to do it there, there's actually a copy of it running on the International Space Station to get data in and out of the experiment racks on the space station. And so we do a lot of maintenance. We don't do a lot of coding for that, although we've written a few bits and pieces here and there. But we do a lot of troubleshooting and testing for NASA. And so one of the things we did, and actually one of our graduate students some years ago took on a project. This was in the early time when this software. By the way, it's called the delay tolerant networking. I'll put a link to that on the website at some point when I get a chance to do that. that software a few years back got sort of its first implementation of network security, in particular the capability of encrypting traffic, getting sent out, say, by a Mars probe or something, or in this case, the space station. And obviously the same as on the internet. Somebody intercepts the radio traffic. You want to ideally prevent someone from intercepting stuff you don't want them to see necessarily. And it's again with NASA, a lot of the science data is technically public. It will be made public. It's usually made public after it's been processed. You really don't want people to intercept it for just for reasons of just sort of handling the release of the data in a reasonable way. But it's so it's not like a secret. On the other hand, if you have manned flight, so if you have a moon landing, you certainly don't want some intercepting the health data, the health monitoring data of the astronauts. So it makes a ton of sense. We want to both authenticate and encrypt traffic, and so. Coming back to software lies to you, this was implemented. We ran the tests that were supplied to us. We did some of our own testing. Everything looked reasonable. We changed some settings, and everything seemed to work properly. So the project we asked the student to do is to use Wireshark. So go in here and look and see what's traveling over the wire. And figure out if we set the client server up for a certain type of security, is it actually doing what we expect it to do? The answer was no, in a couple of different ways. So one of the things that we realized very quickly was that the engineer who had implemented there's a lesson here somewhere. So the client and the server software were written by the same person. And there was, at the time, because it was so new, there wasn't an additional implementation. There was no secondary implementation we could use to verify what we had done. And so the first thing we realized is that so the student on purpose was not allowed to look into the code on the client or server side. So she was working from the standard, looking at the packets in Wireshark, and trying to decode what was being sent. And she couldn't. At first she just could not break stuff apart. It didn't look right. It turns out that the engineer was sort of, as he's writing the software, kind of switched from one draft. I mean, again, this is very early on. In the standards development for the software, he switched from one draft of the standard to another draft of the standard, but only partially. So nothing she was looking at was matching what was actually implemented in the software, right? So the first thing we realized is that if our client, if there was a secondary implementation somebody did, it probably would not have worked because they would have either used the older or the newer draft, but not that particular mix of the two drafts. All right, so that was the first problem. The bigger problem was that there was actually a bug in the configuration I mean, obviously, if you do security, and we'll see some examples of this in a little bit. If we do security on the network, generally you have to do some configurations either by hand or through a handshake between client and server. And in this case, it's a manual configuration of saying we want to do encryption this particular way. And there was a bug. It was you could mistype a configuration parameter and not get a warning, and the end result was that the client would happily send an unencrypted packet when you had requested encryption. Which, hi ODG, welcome. So we're talking about encryption on the network and how to use Wireshark to debug, especially when there's encryption. But we're kind of taking some detours to kind of get ourselves there. So this example,
half the fun, right?
Yeah, that is half the fun. So in this particular case, because the same, in fact, the same code by the same engineer is reused on both sides. If you misconfigured the client, instead of the client saying at startup, I don't understand that, it silently said, I don't understand that, so I'm just not going to do it. And so instead of encrypting the traffic, it would simply send out in the clear, which is really kind of a bad idea. So we tracked all of that down, not by doing testing here and here, but by looking at what was actually being sent out of the network. And in this case, that was really pretty much the only way to conclusively determine that the right things were being done. All right, so I'm a big proponent of having the ability to investigate
the black box debug.
Yeah. So so you can't look at the client, you can't look at the server, but you can see what's going on. Obviously the other reason this is useful, and I haven't gotten as far down that path yet, and so it may pop up in another couple of streams down, as in the next week or two. So with something like even with OBS Ninja, even though we do have the code, I mean it's a pretty complex piece of code that we didn't write. So while we could spool up our own version of it and attach debugging capabilities, I'm really curious to see how much I can learn about how the OBS Ninja site works by watching what it does on the network. All right, so that's the motivation. And so again, a little bit later on, PX Lip's going to talk more about what the sort of the modern approaches to debugging are for our these sorts of client-server web applications. But for now, what I want to do is sort of motivate the idea that I really want to look at what's going on the network. And of course, there's not a problem, but there's a barrier here. All right, and so let me see if I can do this live. What I'm going to do is pop into another window here, and there's no particular reason for me to use the incognito version of Chrome, other than you'll see in a moment that rather than I needed a copy of Chrome or an instance of Chrome that wasn't tied to any of my profiles. So what I'm going to do here is pop Wireshark, and I know it's not readable right now. I'll pop that. I'll enlarge that once we have a capture going. So obviously this is going to go nuts, which is why I'm not going to do a lot of live captures. But it's going to go nuts because obviously I'm watching my stream. I have OBS going. I have an OBS Ninja connection to bring PS Lip in. So this capture is going to absolutely go nuts. So I'm going to start a capture here. And once that's running, I'm going to go to the site that we use for internal. This is the site that we use internally to manage the software project, the the NASA delay tolerant networking software. Okay, so I'm going to pop this. I'm going to stop the capture here. There we go. Now let me pull this down a little bit. Get this out from under PX Lip there. Now let's see if I remember this. So one of the reasons I went to that particular site, and a lot of web pages we might go to are behind load balancers, content distribution networks, those kinds of things. So in this case, it's a single server, so it's a little bit easier for me to, in all this mess, focus down on just the interaction with that server. All right, so if somebody is on yeah, so ODG says, careful, we started to sound like one of his streams, normally asking for too much of my PC. Yeah, it's not so much the PC, but yeah, there's just a whole lot of stuff going on here. Whoops. Hopefully that is somewhat readable at this point on stream.
Yeah, it looks pretty good.
Okay, so the so if obviously this is just a web page, right? And so it's just an example. But if there's something going on here that I wanted to do, I'm kind of at a loss. So if you notice this interaction between the server and me does not actually, if you look in the protocol column, there's no HTTP traffic, at least nothing recognizable. And if I bring one of these guys up, so this is traffic coming from the server to me, and look at what's going on here inside TCP. There's essentially there's nothing I can see, and that's because this isn't a secure website, and the traffic is encrypted. And you can see some references of TLS version 1.2 here, and that is the encryption, the stream encryption standard that HTTPS invokes. When you go to an HTTPS site, then that's what's being invoked here. So if I needed to wanted to see anything beyond the network interaction, right? So what you can see here, and Wireshark sort of happily color codes some of this stuff. So this is the original TCP SYN packet. So this is the synchronization request. That's the initial server reply, and then here's where we're completing the three-way handshake. And then you can see, and we'll get back to this in just a second, the next thing that happens here is that the client and server initiate a TLS. What does it actually stand for? SSL is the old name, Secure Socket Layer. Transport Layer Security. Transport Layer Security. So the next thing that happens here is that the client and server go through a Transport Layer Security exchange. And then once all that is done, and we get to a point where we're actually exchanging information, like here, then then I can't actually, other than seeing that this is HTTP, I can't really see anything. There's encrypted application data. That's the only thing I can see. So if I want to analyze what my interaction with this website contains, I can't do that. Not this way. All right, so let's let me pop a new. This time I was prepared. I created some blank boards for myself. So let's take a look and see how this actually works. All right, so the problem, the problem we're trying to solve is that it would be nice if I could, with precautions, still examine this traffic. But that means that, obviously the client and server know how to carry out an encrypted exchange between each other. But how do I get Wireshark to be part of that, right? So how does Wireshark sort of know, what the same thing these guys know, and maybe be able to show me things that I can the content of the packets that are right now encrypted that are hidden from me. Right. So for that, did I say there's lots of detours? So for that, we're going to have to talk about how modern. So we have if we have a modern website, HTTPS secure web protocol. How does that actually work? And there's sort of two bits to this, and this is kind of useful, I think, for lots of reasons anyway. So so if I want to create a secure web traffic, then what I have to be able to do is provide, and this is going to be just really awful because I can't draw things. But what I want is for the client and the server to have an encryption key, so that so respectively when the client and server send data out to each other in the in transit between the two. So these are not little people walking; these are supposed to be keys. When data is in transit between the client and the server, the data is encrypted. And the problem I've got to solve, if I'm someone trying to design this HTTPS protocol, is I need to make sure I need to securely get these keys to a client and a server. And so and there's some constraints here. Because especially in web traffic, this has got to work for clients that are so anemic, right? So it's got to work for a mobile device, it's got to work for a netbook or a Chromebook or something like that. So I need to and notice my volume is down just a little bit lower than I expected it. So let's tweak that. All right. So so I want a fast, efficient algorithm for encrypting and decrypting. And to do that, the algorithms that are able to do that properly use what I call symmetric keys. So these two green keys are the same. Problem is, I've got to get that key safely to the client. So if you're running a wireless access point or a router or something like that at home, then that's actually what you're doing when you're putting a password in. Oh, by the way, yes, wireless router or access point at home. If it's running the factory default password, stop the VOD right now. Set the stream aside. Go change your password. But if you're doing the right thing, you're setting up your router access point. You put in a password for your Wi-Fi. That is or something derived from that is used as an encryption key. And so that's relatively straightforward because you kind of know what it is. You type it into one device, you type it into your phone, your laptop, whatever. And so that's how you've done the distribution. That clearly isn't going to work between a client and any sort of random server. And so I need another bit of mathematical trickery. What I need is something called asymmetric or public-private key encryption. So now get ready for one of my favorite rants. Yes, ODG says same for security webcams. Here, a lot of them are now used in botnets. Yes, never, ever, ever leave a default password on anything. So there's a bit of mathematical trickery called public-private key encryption. So rant. Never let engineers create the names for things. They screw it up every time. Public, private. They start with P. How do you draw that? How do you put that? Don't do that. And those are the same people that for domain name registrations came up with the idea of registries and registrars. I mean, my students on exams think it's a trick question because nobody can remember which one's which. Don't let engineers write the documentation. So public-private key encryption is kind of a fun. I do not, by the way, claim to know the math. It's pretty convoluted. Very, very clever, but quite convoluted.
The older version's not so bad. It's the newest version. The older version's really just has to do with factoring prime numbers,
right?
Or the reverse, factoring the product of prime numbers. Not too bad. It's the new one is elliptic curve cryptography.
Yep.
That was the end of my cryptography course many years ago, and I remember just staring at it and being like, I thought I was done with calculus. Apparently not.
So we'll let you fill in some gaps here. Let me sort of do the. I'm going to just sort of point out from a user's perspective why this is useful, and then we'll let you kind of jump in and do the 10,000 foot. Don't give us a math headache. I'm a physicist, not a mathematician. Sort of ideas why this actually works. But the clever thing here is that you have two keys, and I use two different colors. So usually one of them is public. I'm just going to be ornery and call this one hidden. This is the private one. So this is the private and public private. And it's technically, I think it doesn't matter which one's which, but you really have to decide. Otherwise, you have a management problem because you can get it backwards, and then you have a problem. So the clever thing here is that anything I encrypt with the yellow key can't be decrypted with the yellow key. It needs the red key to decrypt, and vice versa. Anything I encrypt with the red key can be decrypted with the yellow key, but not with the red one. And if I know the yellow key, the public key, I can't deduce the red one. And the reason this is super fun and interesting and useful, come on already, there we go. This gives me some really cool capabilities, right? So if the server has a private key, a hidden key, and the client has a public key, then the client can encrypt something with the public key, and nobody else can decrypt it except for the server. So I can create an encryption mechanism where I publish my public key and say, if you want to send me something securely, use that public key that everybody can see, use that to encrypt your stuff, and only I'll be able to unpack it. I will be able to decrypt it. Anybody else who has that same public key and see what you're sending can't do anything with it. So that's half of what this is used for. The other half is that I can use it as a signature. So I can take something like my name and maybe some other stuff thrown in, but I can take something like that, encrypt it with the private, the hidden key, this guy here, and publish my public key and say, look, I'm going to send you this encrypted message, and you decrypt it with a public key, and if it comes out is my name, then since I'm the only one who has the private key, I have to have been the one who encrypted it. That's a really, really cool properties. So you want to talk a little bit about how we actually got there?
Yeah, sure. So to keep it really, really clean and not even get into, because there are a number of different implementations of it. So asymmetric encryption relies on what's called a trapdoor function. And basically what that is that it is very quick for me to calculate the function, to take a value, essentially encrypt something given the function. But it is extremely difficult to do the reverse unless I have a particular piece of data. So the example that is often used as the simplest is if I have two really large prime numbers and I multiply them together, I get a non-prime number, which means it's going to have a number of values that could be divided by it, right? So calculating which two prime numbers were used to produce that value is really, really hard, right? I can start dividing by every prime number that is less than this giant number I have, but that's hard,
complicated, right? Yeah.
Right. For a human, obviously for a computer, the right. True trapdoor functions used in cryptography are based around that, but they add a whole lot of extra steps that make it much harder.
Oh, but one sec. So ODG, you said the first message sent is an encrypted private key. I get to that in a second. So it is generally the private key is never sent. The idea when you generate one of these pairs is that one of those two, the hidden or private key is never sent anywhere. You basically put it in a vault. You put it in a protected directory on the server. It is never transmitted anywhere. The public key you publish broadly, but I'll get to that in just a second once we get through the mechanisms a little bit here, because there's some trickery in actually making use of this for something like a web server.
Well, so in the example I'm using, the private key would be one of those two prime numbers that was used
Right.
to multiply together. So given one of the two values that was multiplied together, it's really, really straightforward, right?
To
It's
get
a
the other one,
single
right?
operation, single division operation, which is, an O of n operation in O notation, right? To get the other one. So I
Mm-hmm.
can calculate those
Yeah.
two
So
values out
the private
given
key
one of the values.
has to always be well protected. So
Exactly.
I guess would it be fair to say that it is generally not. I mean, it's computationally very difficult to use the public key to derive the private key, but the reverse is presumably not necessarily hard.
Right.
Okay.
Correct.
Yeah.
Right. In my example,
Yeah.
that example, don't ever write encryption using
Right. Right.
multiplication of prime numbers. But in my example, the one of the primes would be my private key, and the multiplied value, the composite value, would
Hmm.
be the public one. Because
Yeah.
the public one, how do you find my personal private prime number
Yeah.
or prime
You'd
numbers?
have to factor a very large, and I know the very early asymmetric encryption keys were based
Yeah, I think
on that sort of on
1970s when this
right.
first sort of
Yes.
Diffie-Hellman were the two computer scientists who came up with that. But yeah, when they first came out, yeah, I think factorization of prime numbers was in
That
fact
was in
the
fact the
encryption
very first
algorithm.
one. Yeah.
But obviously, in modern computer, the tower under my desk could power through even a 4,000. So
Yeah.
most public-private keys are about 4,000 bits. My computer under my desk could power through factoring a 4,000-bit number in an hour tops,
Mm, yeah.
right? I mean, it's not
Yeah.
that hard.
Yeah. And so and I think uh, that's a there's a lesson here again, one of the sidebars, and yet ODG we'll get yeah, I think it is the public key, and yes we'll and I'll get to the details here in just a second, but I think this is a really important point, and one I wanted to make, and this is as good a time to do it as any. um, the encryption algorithms and encryption like key sizes and those sorts of things are never static, right? So what was a good secure algorithm in 1995 is probably not very good today. Right?
CMD5.
Yeah. So and I think I think sort of the there's basically a work argument here, right? And as computers work, so if encryption is implemented properly, and there are lots of ways of screwing it up. I mean, a lot of companies have. ODG mentioned security cameras, and and other Internet of Things devices. And when they first came out, a lot of those companies decided to cut corners and not pay license fees to establish security algorithms and security procedures and libraries and implementations. And they all screwed it up. They were all broken within a few weeks and became botnets, or people were watching other people's kids sleeping on the baby monitors. It was a mess. So let's assume though that somebody competent has implemented an algorithm properly, and done things like having the right initialization, so you don't get trivial keys, which can happen, and those kinds of things. At that point, the the algorithm has to be properly chosen. Otherwise, it's sometimes possible to look at the encrypted text and do essentially a pattern analysis and guess at least parts of the key, if not all of it, because you can sort of tell the pattern of what's being sent.
Yeah,
You know,
it's why most not the trapdoor function for the actual encryption, but the block
yeah,
encryption algorithms, they tend to take you have a seed. Basically, you
Mm-hmm.
start
Yeah.
XORing stuff on top of each other so that you hide any patterns
That's
based
that.
from random data, and then
Yeah.
a lot of them will use the previous encrypted block to
Yes.
randomly seed the next block and things like
Yeah.
that. So there are
Yeah.
good algorithms hide that, but yes, it is
Yeah.
distinctly a problem.
So let's assume that all those things are done properly. All right. At that point, an attacker is really down to either breaking in someplace and getting a hold of the key, or trying a brute force attack. And this is where so if algorithms get cast aside as no longer secure, in some cases because they have a flaw. In some cases, something in the math was wrong, and it's possible to attack them. Yeah, ODG says they're made only strong enough so it can't be broken in the time the data is valid. Yeah. Yes. So the and the problem is, even if it's a good algorithm, at some point, what was really hard computationally 10 or 15 years ago gets easier if you can do it more quickly, right? And and so both the size of the key, the password, or whatever it may be, matters, and in some cases also the complexity of the computation. I mean, so when we talk about brute force, I mean essentially you have to try with some. Maybe with some trickery, but in essence, you have to try like every combination, right? And so, my favorite example is years and years ago. I mean, years and years ago, I was visiting my dad, and with some of my kids, and he's said he had a problem. His car went in for service. They replaced the battery. The car came back. The radio won't work. It wants a code. The code is the same as the keyless entry code, but he doesn't have the keyless entry code. He always uses key. So we look through the manual, and there's a sticker with the keyless entry code, except 3/4 of the sticker is gone. There's only one digit. Now, fortunately, this was actually kind of weird. The numbers were 0 through 9. There were 4 buttons. There were 4 digits you had to key in, but there were only 4 buttons. There's like I have no idea why, but each button had multiple numbers on it, just so they make it look as if there were more codes than there really were. So in the end, it's like there weren't that many combinations, but there were just enough that I think we figured out we needed to, I can't remember the exact layout of the keypad, but I think we figured out since we knew one digit, we figured out we needed like, I don't know, something of the order of a couple of hundred tries. And so, we got the adults got an outlet beverage, and the kids got soda, and we sat out there by the car, and we took turns pounding into the keyless entry point until the doors unlocked. And we said, that's the code, and sure enough, it was. Right. So if they had put more buttons on if they had required you to key in more numbers, it would have taken probably too long. We said, nah, that's not worth it. It's not, whatever. So it wouldn't have been feasible because we weren't there for long enough, or we weren't willing to sit out in the carport long enough to pound those numbers in, right? So. Yeah, ODG says nothing will remain unbroken forever. I think that's absolutely correct. And just again, we're sort of digressing, but that's part of fun of these streams. So somebody went through like corporate requisitions, federal requisitions, and found a requisition where a government agency that nobody had really heard of was bought. I think it was something like 5,000 or 6,000. I think they were not PS4. They were the
PS3s.
PS3s.
Early
Yeah,
PS3s, and it was the Navy.
right. And I mean, this and so either they were trying to equip a lot of ships with entertainment. We were we were all pretty much convinced that they were trying to decrypt stuff.
Yeah,
Do code breaking with because these are basic graphics engines that are very, very good at it, and graphics cards are very good at this sort of stuff. So
I should clarify earlier. So the Navy publicly did that. They created a giant parallel supercomputer out of several hundred PS3s before.
That's right. That's right.
Before Sony made it impossible to do that.
Yeah, I got this. I got this mixed up with another story that was NSA related. But
I say it's very possible no such agency may have done something very similar. They just didn't say anything about it because it's no such agency.
Right. So just as an aside, one of the reason I was talking earlier about SSL versus TLS and even the HTTPS algorithm, it's extendable. There are multiple versions of it, and it kind of moves along. Like ODG says, we try to design things so that if it takes a century to break the key, by then the data is probably not terribly valuable, right? And of course, it also depends on how much effort, right? So if someone who can buy a few thousand PS4s can probably break more stuff than somebody tries to do it with their laptop, right?
And everybody's constantly, computer scientists interested in this particular field are constantly looking for is one of the given functions that we've chosen, the elliptic curve is the newer one, right? Are these truly trapdoors, or is there a mathematical approach that you can take that solves it? And again, it comes back to, there was a rumor 2-3 years ago that the NSA had come up with essentially a backdoor solution to one of the commonly used trapdoors.
Right, that's right.
Because they figured out an efficient way of factoring prime numbers.
Yeah.
Essentially, is what it came down to. So that's always the other concern.
So coming back to our problem here of encrypting traffic on the network, and ODG, this is where your question comes in, right? So to let the client encrypt data and send it to the server, what I would like is for the client to have access to the public key. And since it is public, it is not, nobody can decrypt something I encrypt with it. I can publish it, right? And so the website could technically say, here's my public key. There's a problem. How do I know that key is legitimate? I need to have something that gives me confidence that public key that I'm about to use to encrypt something sensitive and send it to a website, that public key really belongs to that website, that I'm not being spoofed somehow. That is a problem, right? Because now I need some assurance that public key really belongs to that server. By the way, this is a long-standing problem, and I remember when the private key encryption first came out, it was used to sign and/or encrypt email, and so you had to have the public key for the person you're sending or exchanging email with. And so I remember going to IETF, to Internet Engineering Task Force meetings. And they always had, for a couple years after this came out, they had in each of their meetings they had sometime in the evening, like from 8 to 10 or 7 to 9 or whatever, they had a key signing party. There were beverages, there were snacks, there was a reader at the front of the room, and the reader would read out a key, a name and a key, and then a person in the room would stand up and say, "That's me." And you would look, and if you recognize the person, you check it off on your copy and say, "Okay, that's the right key." If you didn't recognize the person, but you wanted to use the key, you were hoping that somebody else that you knew in the room would stand up and say, "Yeah, I know that guy. That really is William." And then you check that off, and if somebody said, "Yeah, that's William," but you don't know William or the other person who says that's him, then you leave the key unchecked and don't use it because you're not sure that it's the right person.
Well, a really great example of that, of sort of a modern take on that, is there is an application, and there's some questions about its usages anymore, but called Keybase, where you
Yes.
publish your GPG key or PGP key, but then you essentially assert I am me by signing things on Twitter or Reddit or your
Yeah.
personal website or GitHub or things like that.
Right.
Basically, provide additional identity to that key.
Yeah. So the so before I can trust, so I need a chain of trust, right? And so so this is, and I'm not going to spend a ton of time on this, but this is where certificates come from. And the idea, yeah, that is a different kind of party, yeah.
It's a very different kind of partner.
Um, so, whoops, come back here. There we go. So the idea is that if so what I want to do is have someone I trust certify, hence the name certificate, certify that this really is the public key for that server, right? And so every browser, so let me, oops, Diagonabit. I wish I know what turns that on, so I can turn it off. So certificate. So
I'm not gonna lie, certificate management on a server is a pain.
yeah,
Totally different topic. Totally
but
not important. But man,
yes. So the idea is that I have and it's usually not me. It's usually built into the browser, right? So Chrome, Firefox, whatever, have a list of trusted certificate authorities coded into them with their public keys. And so, without getting into the details, this is a topic for a whole other stream. If when I make a connection with the server doesn't just present. So this is where I come back to what you were saying. The server doesn't just send me their public key; it sends me a certificate that contains the public key in such a way that I can check based on a certificate authority. So in some sense, the key, the name of the website is encrypted with the certificate authority's public key, which I trust because like Microsoft or Google or whoever made the browser chose to include those public keys, right? So I trust the publisher of the browser to verify the certificate authority is legitimate, and then if one of those keys properly decrypts the certificate, then I trust that key. Now, a couple bits of warning here. There's not as much certification here as it might sound, right? So generally, most certificates simply verify that the certificate was issued to someone who controlled the name of the server in the domain name system. Right? Like the info.profcruise.net, my website. Google serves that website and provides a certificate for it. So I have to prove to Google that I actually control profcruise.net, the domain profcruise.net, before Google will let me do that. And generally, what they ask me to do is that here's this random string of characters, stick it into an entry in your in your domain name system server, And if we can see it there, then we know you can manipulate the servers. That means you control the domain. That's generally all you get, right? So if you go to Bank of America, and in essence, if your browser doesn't give you a warning, you get a little lock symbol. You know that the public key you're getting matches the name of the server you're connecting to. And if you're careful and you look and make sure it's really Bank of America, then you're talking to your bank's website. In theory, at least, I can go a step further and ask the certificate authority to verify my company, that I have control of my company by submitting, company registration documents that they can check. It takes a little longer, costs more, you can do that. For a while, browsers would display the company name in the right next to the lock icon, and that I had to look it up. That got changed about a year ago, less than a year ago. Both Chrome, Firefox, and Edge pulled that because they decided the users weren't actually looking at that, and so that got pulled. You can still see it if you click on the lock. There's one of the things you can see is the certificate itself, and you can see who whether or not it's been issued. In this case, it's just Google's. It just says it's Google's, and I can't enlarge this, so it's kind of hard to see. But if you do this on a website, generally at the very least you want to see that it's been issued to the website, to the domain you expected. ODG said, I remember the company name of the browser, but didn't notice it had gone. Yeah, I was looking for it too, because I knew the different certificates existed. And if you go to certificate authorities, a lot of them will still talk about how it's displayed in green next to the lock, and I couldn't find it. So I had to do a little bit of searching, and the browser publishers jointly decided it wasn't as useful as people thought. But if a company does so let's see, what is Bank of America, just out of curiosity? Let's see. All right, so actually I didn't have to go that far. When I clicked on this, it said under the certificate, it says certificate valid, issued to Bank of America Corporation. All right, so that's a good thing. That's a good thing. So you can still check it, but it's not as obvious as it might have been otherwise. And you have to be super careful, because I could a lot of the attacks on try to harvest people's login credentials actually use websites that are lookalikes. Either it says Bank of America Online or Bank of America California or something, and if there is no such domain, I can register it, then I can get a certificate for it because I own the domain. I can try to be sneakier. I think ODG has done a lot of sleuthing around in Unicode tables, basically international language tables, and so I could replace the A at the end of America with like a German A with the umlaut on it or something. Now the registrar, either registries or registrars, in this case I really don't know who has the responsibility. There are some algorithms that's supposed to run to make sure that to catch sort of the obvious attempts to create lookalike sites, but chances are you can. So if you get redirected to a site that you didn't mean to go to, it can have a perfectly valid certificate, and that doesn't really tell you anything. Even the company registration you have to be careful of, because if I create a spoof website, and this isn't going to work really well at Bank of America. I mean, I'm not going to be able to register at Bank of America someplace and get that to work and get somebody to verify it. But say, for example, there's a popular game called Escape from Tarkov, which is super popular. The accounts on the Escape from Tarkov website are valuable if you're a reasonably good player and have lots of good loot in your game. People might want, so that it might be worthwhile trying to attack that. So if you create some sort of a lookalike website by replacing some characters with a national character or something, you could then go like to Delaware in the U.S. or Dakota somewhere where it costs very, very little, if anything, to register a company, and register Escape from Tarkov Amusement Park Escape Rooms or something. So you don't violate trademarks because it's a different industry than video games, and then you can submit a request and get a certificate, and even get a certificate that contains a company name. So obviously you want every site you go to have HTTPS, right? But you still have to do some due diligence to make sure that what you see in the address bar really makes sense. Yes, and then ODG says that's where two-factor authentication comes in, because if you fall prey to this, your password gets loose. If you have two-factor authentication, it really doesn't help the person who scammed it. All right, so that was another detour. So let's get back to why this is useful, because and again, I'm going to super simplify this, but I like this guy. I need a different. Let's use this guy. So in SSL, which is the old name, the old version, and TLS, which is the one now, the first thing that happens is that the public key gets sent from the server to the client. And of course, the client then verifies that certificate and now has a public key. And what the client then does, the client and server both go through some. The client and server go through some steps. To derive something called a pre-master key. Right? Because the goal here is to ultimately switch to symmetric key encryption. Right? So if I have the public key, I now have a way to send encrypted stuff to the server. Right? And so if I accept the certificate and believe that this is the true public key, I can now encrypt stuff and send it back to the server. So in a super simplified way, I create a key using an algorithm that the server can replicate. The only reason this isn't directly used as the encryption key is that there are different handshake standards that result in somewhat different keys with different properties, and to get to a point where, and there are, like, I think when I looked at one of these things, the TLS 1.2 standard. Well, I don't know about the standard, but one of the exchanges I looked at this past week, I think that offered a list of 16 possible encryption algorithms. The client said, "Here's the 16 algorithms I support. Which one do you want it to use?" Right. So, in order to create an appropriate key, the pre-master basically gets converted to whatever key is needed for the algorithm that the server. I think the server selects the algorithm from the list that the client sends, right? And so so this guy here, let me do this because otherwise it's going to get too messy, is called a pre-master. Right, and the reason, I think the reason they call it a master key is, let's see, let me move that if I can. Let me move that a little bit. Move it here. Okay. So I think the reason they call it a pre-master is that once a key is derived for the session, they're transient keys that get that get redistributed every now and then. So it gets a little interesting over the course of the exchange. Right. So what does any of this have to do with Wireshark? Yeah, everybody asks. What has anything to do with Wireshark? Since the client goes through this computation, if I can capture the pre-master and get it into Wireshark, then Wireshark can so let's hop back here, right? So remember, what we're trying to do is grab these encrypted packets that Wireshark grabbed and decrypt them. To do that, I ultimately need the key that's being used, but that one I can derive if I have the pre-master. So how on earth do I get the pre-master? Right? Because I'm not supposed to. This is normally supposed to just live in memory inside the client. Okay. The way you do that depends a little bit on browser. Not all browsers will support this, but Chrome has a number of command line options, including one that logs pre-masters. And let me see, I've got this right here. I don't know if that's big enough, but I can make it bigger. So it's a second line here. It's this block here. So what I've done, and that's the reason that you saw me use an incognito windowed browser. What I did is I created a shortcut, a Windows shortcut that runs Chrome. It requests an incognito window. Yeah, oh Jesus, what does that have to do with Wireshark? Here we go. I grabbed an incognito window in part because I don't want, since I'm actually making my traffic vulnerable, I prefer that it doesn't try to log into Google and deal with my profile and do all sorts of stuff, my email and whatever else. Right? So I want something that isn't tied to a profile, that isn't trying to do all that stuff. Here's the key part. I tell, and the command line option still uses the old name, SSL. I specify an SSL key log file and tell it where to put it. Chrome will then happily dump keys into that file and make them available. And so, if I can, and I'll show you in a second how to do this in Wireshark. That would be how I get into Wireshark. This works, as far as I know, only for Chrome. Firefox has the same capability, but you have to set SSL key log file using an environment variable, which you can do on Windows or Mac OS or Linux. To the best of my research, and if somebody knows that it's changed, please let me know. But to the best of my knowledge, Edge and Safari do not support logging pre-masters. So I think you can't do this with Edge or Safari.
Edge ought to, because it is a WebKit browser.
I know it's WebKit. The documentation in Wireshark, I thought, said it could. It did
It could
not.
be that they haven't enabled the flag, but
That's possible.
The code is probably there.
Yeah.
It's just they may have buried it.
So Chrome's a good choice. Firefox is a good choice. And generally, most developers, and here, Slip, jump in on this one. Most developers, I think, tend to start with Chrome and then start branching out and testing, or maybe Firefox.
Yeah, Chrome and Firefox. Yeah, for the most part. There's some other ones out there. There's Brave and
Yeah.
Vivaldi that are all sort of
Yeah, and I don't know if those. I
have
don't know if.
their
And so I have not
fans.
tried to see if those can do this. So let me see if this works on the fly because I haven't done it this particular way, right? So as you can see in here, I've I've set this up. Chrome will be logging keys. Right, and so I should be able to go in here. Now you won't be able to see. I'll try to talk you through it. Unfortunately, these dialog boxes I can't make big. So this is the Wireshark preferences pane, and I know nobody can read that. There's a protocols section. If you scroll way down, because Wireshark knows lots of protocols, there's a TLS section. Notice it's not called SSL. It's called TLS. And in here is a pre-master secret log file name, which I will now point at my log file. And it worked. So notice that in the past, when I looked at it, we had no HTTP traffic. Now that Wireshark knows the keys that Chrome used over the last session, and it just doesn't get reset at the end of a session. So basically, Wireshark grabs all of the keys that are in that file, and I'm not sure how it matches them up, but it does match them up and find the appropriate one. So now I can see the HTTP traffic. Right, and so I can let's see if I can remember how to do this. So now I can actually here this is the initial GET request, right? And again, it's something you can't read, but down here one of the tabs says decrypted to TLS, and so. This would actually have the, and this is compressed, so you have to go to the decompressed header, and there's there are the various bits and pieces of that, and if I look here in the decode, there's the there's our request for the GET request, which Wireshark happily showed up there. So that's what all this long detour had to do with Wireshark. All right, so through this mechanism, and obviously you want to be super careful. So what I've done here is the only time this key file gets populated on my system will be if I start that incognito browser first. Because in my experimentation, if you already have Chrome running and I use my shortcut to open an incognito window, that command line command line option is never executed. So I have to shut Chrome down, start with that window that has the log file option on it, and then as far as I know, every window I open after that will log. So obviously, obviously still pretty dangerous, in the sense that a lot of your traffic can be decrypted at this point. But if I open a browser normally, the keys don't get logged, so this makes it relatively, and that, to my mind, that was a little bit safer than setting an environment variable. Now there are ways to set an environment very transiently in a script and then launch the browser. That's what you have to do with Firefox, I suppose. So there are other ways of doing that. This is how we we'll be able to use Wireshark to, for example, look at the OAuth interactions going on between a client and the back end. What I don't know yet is if Electron obeys this, so we'll have to experiment with that.
Yeah, that'll be a fun question.
But so this is what I wanted to do. So what this does is it means that if I go to OBS Ninja, which is an HTTPS site, I can now start looking at how this is actually working on the wire, what kinds of things it does, because Wireshark will be able to decrypt the HTTPS traffic. Okay, so that is where Wireshark comes in. Incidentally, I'll post these in the description on the website. There is a with Wireshark you get a program called EditCap, and one of its capabilities is to basically make a Wireshark capture portable, in the sense that you don't have to carry the key file with it. I can inject the key file into the packet capture file, so that going forward, any traffic in that file can be decoded even on another system where the key file doesn't exist. Right. So that gets us back to so we're now kind of gone through the cul-de-sac about 3 times around the block. So we have solved the problem of this, right? So I can use Wireshark. I can look at the even encrypted traffic, as long as I control at least the client. I can capture the pre-master keys. So what we want to do to wrap up here, we've got about, I don't know, 10, 15 minutes, something like that. What we wanted to do to wrap up is have PXLib sort of get us caught up a little bit on how debugging works, how's debugging evolved from the days of ODG. Earlier said, give me a GCC compiler and I'll be happy. But of course, that's not what we're doing today, right? So what are the tools and the procedures that we use for Electron apps, or for browser-based apps, those kinds of things?
Yeah, admittedly, Electron apps are a lot more exciting. I haven't. There's always
Let's
the joy of,
let's start with the browser ones then.
There's always the joy of figuring out the new debug environments, right? Because
Yeah.
every language has its own thing. And going back to GCC,
and by the way,
it had its
by the way, let me know if you want to share your screen ever. And
I don't know that I'm really going to have
Okay.
anything particular to share.
Okay, that's
it might
fine.
come up, but I was thinking about this earlier, and I think we showed a little bit of the browser tools that are often used for debugging.
Correct.
And there's some sort of more talking about.
And if you
the
want me to pop
philosophies
pop something in here, I can do that. But yeah, I think that makes more sense. Let's talk about some of the philosophies of how we actually do that.
Right, because what you've spent the last little bit talking about is really sort of what I would essentially describe as black box, and I think I use this black box debugging is the term that you usually see used. Right, it's let me throw some input at this thing and see what comes out of it.
Right.
And that's really useful in a lot of circumstances, either when you have untrusted code or code you just don't remember what you did with because 2 years on, and you find that comment that says you should really change this, and it was written in the first week of its launch. That's fun. Point being, so black box is great, right? You give a particular input, you poke the bear a little bit, and you see what happens. What is not necessarily more common. It's funny. I was sort of in my usual poking around of the development sort of internet. My day job revolves around PHP and in particular a framework called Laravel. And there's a pretty robust development community around it. So there's a lot of external tools, and in the PHP community, and OG, you may have sort of an opinion on this. So you were talking about PHP earlier, right? There is a really excellent debugging application called Xdebug. It allows me to set breakpoints, which, if you aren't familiar, a breakpoint lets me essentially tell the PHP engine in this case, or the Node, the JavaScript engine, anything, that, hey, run the code up until this point, until you hit this line of code, and then stop. And store the stacks and store the current variable values, store everything about the context that code is running in, and let me inspect it. And so Xdebug provides that functionality, which is the big one, right? It has performance monitoring, other tools. It'll fire, it'll catch exceptions that you don't properly catch yourself and pause on them. Yeah, OG says not sure if it was around when he was doing it. Debugging was lots of logging to a file. Yeah, so that's the other side of this. So Xdebug is great, right? It's wildly powerful. It's also a pain in the neck to configure. It tends on a new machine, it tends to take me minimum, and I've done this about a dozen times now. Tends to take me about a minimum of a half hour to an hour to remember exactly what settings I need, all the pieces to get it configured up and running with my IDE.
Just as
It's
a note for ODG, if you're using GCC, I think the tool for GCC is GDB,
yeah, yeah.
and so you
It's
would
the
have had
debug
that.
bridge.
Yeah, you would have had that whether you used it. Again,
Yeah.
I never did in the work
Well,
I've done just because of I used other approaches. But yeah,
and this is so this was sort of where I was going to. The other
yeah.
side of the argument, right? Because there are some cons to, the configuration of xdebug. A lot of people use what in PHP, because it tends to be a web server, right?
Hmm.
You can't just like log to a file and sort of see what it's doing. It's the web server is constantly running, and the log files
Yeah,
are,
they're huge.
not, partially only moderately useful. You have and especially in a development environment where you don't mind killing the server, you have what's called the dump and die, right? You basically dump out whatever variable or variables or context you're interested in. It's like, hey, what did this value look like at this point in the code, and then stop execution. Let me
Okay, I
just see
see.
what this looks like right here. It's like in
Okay,
JavaScript, you see a lot of console.log, right? Very similar
right.
concept. And it works. It's very effective. There's really nothing wrong with it for the most part. But to the point I was sort of making earlier, a tool just came out, right? That was essentially revolves around simple, making that easier. So it is sort of, those are in the PHP world, and I would argue in any other world, right? The number of times you see a JavaScript developer being like, "Oh, I'll just console.log this," or let me, dump this, let me just spit it out to an
Hmm.
HTML element in the browser, or oh, I'm just gonna dump some text back from my Express server. It's quick and easy. So those are sort of, in some ways, there's the, I guess I'm going to call it the three philosophies of debugging: black box, tool driven, and dump and die, because that's the only thing I can come up with. And so those are sort of, without trying to put my own personal bias. I do have opinions. I'm human, so sue me. Um, Without putting my own opinions on it, those are sort of, to my mind, the three general philosophies I would see around. Um, that's
Is it,
old school now.
just as an aside, though, the
Hmm.
developer console we looked at in an earlier
Hmm.
stream. I'm not sure it has breakpoints, but it does have
It
some variable watch and some other. I mean, it
Yeah,
basically has
it
sort of
does.
basic debugger features
It
to
has no.
it, right?
It is a fully featured. It is essentially a UI interface to the Node debugging tools. In fact, it supports breakpoints. It supports catching, breaking on
Mm.
exceptions, uh, uh, all the whole tool set. But even so, to be blunt, most JavaScript developers aren't comfortable with it, and it's
Mm.
sometimes easier just to continue with the tool set, than try and learn something new. So
Yeah.
my bias is showing. Excuse me. I do think tool-assisted debugging is more powerful. I've had situations where I'm, because I know, so modern web development, right? There's a running joke about a leaning tower of dependencies that can be broken by a three-line library that
Yeah.
some guy abandoned 20 years ago. Um, but what that means is, sorry, my cat is being a cat. Um, what that means is that you end up with, in situations where the offending code, whatever is being generated, is three libraries deep. And so instead of, sure, I could try and guess where it's going wrong, but it's much easier if I put a breakpoint where the last place in my code that I know works, and then you can step into is a debug term, right? I go to the function that I know is doing something weird, hit step into, and it'll take me into the function there, call. And then I can continue all the way down the call stack, theoretically to the original initialization function in whatever language I'm in. That I find to be far more powerful, but not to put shade on anybody who chooses to use the other tool set. I find the power to be much more in the tools. But I will happily admit that there are days when I don't need that level of assistance, and it's just much easier to just dump semicolon die and just find out what the variable is at that point, or console.log, right?
Hmm.
Um,
Yeah,
yeah,
in ODG, embedded systems are very
are a
different.
whole.
That's a
I
whole different
think
ballgame.
I think the conversation I've seen around embedded systems developers are don't a lot of people use essentially emulators. You
Hmm.
do an emulator of the embedded system on your desktop, and that
Yeah.
gives you the hooks you need to debug. But embedded systems I will happily admit, are fully outside of my expertise. So that would just be the sort of the bits and pieces of things I've heard about. So
Yeah, the only thing I know is that's typical for Artem's code, which is one of the embedded system, sort of Linux-like embedded system codes. Um, I think the Arduino development you can do the same way. I think there are
I know,
emulators
yeah,
for Arduino
yeah, I know
where you
for
can
a
do that.
fact. Yeah, that Arduino has been my only foray into embedded systems. It was a brief period of trying
Hmm.
to learn, and I never bought any of it. I just downloaded their debugger or their emulator to sort of get a
Right.
feel for it.
Yeah.
Um, so I don't know. That's my
Yeah,
initial thought. I'm trying to
yeah,
go
and
ahead.
just to jump in, uh, I mentioned the NASA software earlier, and we ended up with really. And I mentioned a lot of our work is debugging, right? So a lot of times we run tests either of our own accord, or we have standardized tests, and a developer makes changes to the software. We run the test fails. We need to find out why. Um, and we find ourselves using all three
Yeah,
methods, and here's why. So already mentioned the example of my student tracking down that security misconfiguration problem, which really only showed up if you looked on the wire. So that was
again,
kind of a special case,
well, but a
black
perfect
box kind of.
example of black box,
Yeah.
right? It's a I know given a and that one boils back to one a if we were going to take this all the way back a tiny bit, that sort of work kind of rolls it all the way back to one of the core programming conceits that's becoming more and more popular is is and where it just popped out of my head, functional programming, right? Yeah, I think I'm getting that right.
Hmm.
Where everything is essentially a black box. You're writing functions composed of other
Yeah.
functions. There's no traditional development approach, and that's very similar where it's you are guaranteed in a given a certain input, I know what the output should be.
Right.
And so that is a very useful testing
Yeah.
technique and debugging technique is
Right.
guaranteed output, right?
Yeah.
A function that only does that one thing.
Yeah.
Sorry, that was a digression again.
No, no worries. And ODG said hardware mainstream non-embedded and common hardware are doing come with great tools. Yeah, even the embedded field, they have them now. A lot less bespoke hardware. Yeah, I noticed that
Yeah.
too. There's a lot more standardized hardware, things like Arduino, and there's some other boards that are become super common. Um, we're doing just fine without you, Digi. We can do our own thread drifts. You're not.
Oh no,
You're just helping us drift along. Call us
we
old drifter.
personally I love it. So
Yeah,
I'm
I do
drift away
too.
with us.
Yeah, absolutely.
I feel
Um,
like I would hum some lines out of that song, but then we'd get DMCA'd, and that would just be
yeah, that would be
unfortunate.
bad. Uh, so, so the so there's the black box part, but of course this is C code, and of course and it's running of course on our client, and we can use debuggers. The problem here is that because it is essentially sort of almost like an operating system level. I mean, it's a router. It routes not TCP packets. It sits above that, but it routes. And digital networks packets are called bundles. It routes bundles, but it otherwise kind of looks like a kernel module. It runs in user space, but it behaves kind of like a communications module in the it was otherwise been a kernel. So, and it's been years since I've actually done a lot of active work trying to debug anything. I've set up networks and sort of help, maintain infrastructure. But when you get roped into administrative work, you don't get to get your hands dirty in the code very much anymore. But when I looked. These bundle routers, the DTN bundle routers, when they're fully spooled up, you're dealing with about 40 processes, and each process is multi-threaded. So you probably have a couple of hundred threads minimum that make up this code, and in general, you have to tell GDB what you want to attach to. It doesn't, there's no such thing as attached to the DTN software, because it's like, which of the 40 processes and which of the 200 threads would you like me to examine, right? So sometimes when we know that, it's still super useful. But sometimes we've just gone in and we don't necessarily do dump and die. Yeah, it's attached to proc. yeah, no kidding.
That's about right.
Yeah, so we don't generally do dump and die, but we do dump. And in fact, because of the nature of that software and the difficulty in debugging, and probably because the developer, the main core developer, somewhere between ODGs and my age, somewhere around ODGs and my age, not your age, Pixlup. So he tends to not work with debuggers very much either. So he actually built an elaborate, and it was needed anyway for other reasons, for operational reasons, not debugging reasons. One of the things he did is he built a fairly elaborate logging system into the software, right? And it's based on macros, so. When you initiate a log call, it will include the backtrace, the source code line number backtrace, and a few other things. So it's really pretty clever, and it's been super helpful. So we actually use all three approaches in that particular software, just because. Right, some things you can only catch with the black box, especially if you don't have, two interoperable implementations that you can test against each other. Then sometimes you need to sort of make sure that the black box output really is what the standard says it's supposed to be, not what that software coded. Because if it's talking to itself, right? If I talk in a mixture of German and English to someone who knows both languages, they'll probably be just fine. Everybody else is up the creek without a paddle, right? So at some point you have to look and see what's actually going on, and then sometimes you can attach and use the debugger that lets you kind of navigate through the software, and sometimes, especially in these multi-threaded asynchronous environments with lots of, part of the problem we were having is a lot of the problems we were tracking down were timing issues. If you have multiple threads that have to lock and unlock memory locations, race conditions become an issue. ODG, I'm assuming race conditions are probably in embedded systems. Those are a big deal. ODG says used to get interesting. We had no storage at all. Yeah. Your console log turned to a whole C library to try and get a network connection to send data on. Yeah, and I remember, what was it? This was an embedded system, but I can't remember what this was used for. It was a. So one of the early is Pierre Slip's going to kill me, but the early visual basic, actually it was an object oriented basic language.
Oh.
It was essentially Visual Basic, but done a little bit better. It was a dialect of Basic that was actually properly object oriented, and I was writing some software using that. And because it was one of the reasons we used it, that software was very good at, and Visual Basic actually in general was very good at designing user interface. Basically designing something that was mainly where you mainly was concerned about a functional user interface and not performance and compute. But then once you have a full screen user interface running, how do you debug, right? Because this is before multi-screen computers, and so that software actually came with a debugger. And ODG, you reminded me, that software came with a debugger that could run on another computer and attached over the network to the running instance of my I can't remember what it's called, something or other basic. So there are some hybrids here, but I think what we talked about today is sort of it's kind of the overall equivalent, or sort of not equivalent. It's the overall breadth of debugging tools and approaches. And so I hope ODG says that you worked on parallel embedded systems, the diskless shared memory loop, so storage was replicated, which is a nightmare when it fell over. Yeah, I would imagine.
That sounds like it.
That does
Jeez.
sound. Yeah, I mean, we've chased so many race conditions where, one thread thought another thread had the lock, but it didn't, and so that first thread was sitting there forever waiting for the lock to go away. And of course, there was nothing out there to unlock the lock because everybody already had unlocked, and this guy was just wrong and had incorrectly thought there was a lock still in place. So, those things are that's a whole different stream of how you debug that sort of stuff. So anyway, any thoughts on how this translates to Electron? Just out of curiosity. You're running JavaScript on a WebKit substrate, but of course you don't have the browser plug, the developer tool plug-in there.
I actually do. So you can, when you launch an Electron application, you can launch the browser dev tools.
Okay. I didn't know that.
That gives me access to the render process, not the main process. Right?
Okay.
So if you remember the architecture of an Electron application,
yes.
you have your main process, which is essentially a node server, just not, but close enough. And then you have your render process, which is the browser. I can get access to all the tools on the render side. It's the main side that you have to, and I'm sure I have not looked closely enough into how to hook. It is a node application. There is a node command line flag that sets the debug port, the debug server port, which I can then hook into and talk to. I just haven't put the effort in to set it up. Like Xdebug, it's one of those things that you just have to have a day when it shows up that you go, screw it. I'm going to spend the next 3 hours figuring out how exactly this works.
Yeah, that's sort of similar to what ODG was talking about, setting up basic network code to be able to hook in, and or that basic Visual Basic app I was running that was basically that allowed you to use a socket to attach to it, so you could do it from another computer. Okay, so as we work through LST, I think this is going to become I think there's something we're going to revisit at some point. As we run it and then try to figure out why something isn't working. And of course, we talked about Wireshark can see the loopback interface if we're sending stuff between a browser and our app. We can capture that, so we can do a little bit of black box there. But obviously, we're going to have the other tools as well.
For at least for the time being, it's going to be a lot of logging of values.
I would imagine that too. Yeah. All right, I think this is a good stopping point. We're at 9:45, so that's roughly where that's a good place for us to wrap. So a couple of notes. On a fun note, I found out today that I will indeed start teaching again. I will teach a class. To teach one class in this coming semester that starts not next week after next. Runs for our semesters run for like 14 weeks or so, so it runs through April sometime. So that'll be fun. I'm hoping to entice some of the students in the class. It should be a small class. It's a class that's a bit of a redesigning. We're keeping it pretty small, so it'll be less than 20 students or less in there. But I am hoping to entice at least some of the students to hang out with us on stream when we do this on Thursdays. Some of the streams coming up, especially because LST certainly is more in needs some time to cook and develop as SPX has time to deal with that. So several of the streams coming up are going to be a little more closely tied to the class I'm teaching. I'm teaching a class that, as I said, I'm going to have to redevelop it a little bit. It's a class that it still has the it's called voice over IP, which is really a misnomer today. ODG says, sorry, you can't. Well, actually, as it turns out,
given the current global pandemic,
given that we're in a global pandemic, it is not an in-person class. It is a remotely taught class. Even though the students are on campus, I've not been asked to set up any physical class meetings. Some of these will be asynchronous, and some of them will be synchronous. I don't know how much. Some of our learning platforms are sort of locked down to university IDs for obvious reasons, but a lot of what I do lives on a public website, YouTube. So I'll keep ODG. I'll keep you. I'll let you know what the website is, and if you want to follow along on it. What I was saying though is you're more than welcome to, and if I can get you into some of the the synchronous classes. And maybe we'll have you in there as a visitor at least from time to time if I can manage. I think I can invite you into the synchronous classes. The asynchronous stuff in the learning platform is a little bit different. The class nominally is called Voice over IP, which is how it started some number of years ago, which is focused, as the name might imply, on voice communications over the internet. Obviously, especially accelerated by the pandemic. Things like OBS Ninja, Microsoft Teams, Zoom, all the other platforms were already. We'll make at least some of it happen, ODG. Absolutely. Modern communications platforms really are more than voice. They're obviously all IP based, but not the same protocols that the voice over IP applications traditionally used. So I haven't decided yet what we're going to do next week. I think what I want to do is do some follow-up work now that we sort of demonstrated how to use Wireshark to get at encrypted traffic. In fact, I'm pretty sure I want to look at OBS Ninja with this tool and figure out how it. Because ODG, you remember you and I did that stream on your channel. We're trying to figure out some of the traffic flow. When you had the OBS Ninja group chat going, and so I wanted very much in the black box approach. I want to go through and see if I can understand the signaling path. What I figured out earlier today is I did a connection between my laptop, which is sitting behind me on a desk here somewhere, and my desktop. And in the end, when the video connection was up, by the way, note to self: always mute the audio if you have two microphones in the same room. It was very painful. But when everything was said and done, and I had a video connection between my laptop and my desktop, it was direct on my LAN. So the two machines found each other even though we were starting through OBS Ninja. There's a protocol called Stun that's used for that, and so I think that's something we're going to start exploring next week. Yes. That stream when we were playing around with that OBS Ninja site on your stream. That was really good fun, and it really got me interested in trying to figure out how to use Wireshark to pull that apart and figure out how to actually dissect how it does things, and hopefully at some point. One of my colleagues is an expert on basically he has a degree in film and video, and so I've asked him for some resources on things like video codecs and audio codecs, because I'd like to figure out, remember when we were doing some of the bitrate settings and quality settings, I really want to understand more about what's going on as far as how the data is encoded and then those sorts of things. And I should be able to figure that out. So I think that's going to be next week. See how far we get, and then I'll start actually thinking through. There's in some ways for the next month or two, a number of these streams will be somewhat loosely tied to what I'm doing in my class, and as I said, I'm hoping that we'll get some of the hopefully we'll get some of the students to hang out with us. That I think that'll be good fun. All right. Anything from your end before we wrap up?
Don't think so.
All right, then. Hope everybody stays safe. Let me see. Is Fern still going? She is.
Hey.
So I think what we're going to do is do a Resurrection Fern raid. If anybody here does not know who she is, she's a singer-songwriter, and a friend of mine who have had the good fortune meeting at a TwitchCon conference, and she's a really good friend. So we are going to start a raid going that way if it'll let me. So we are going to take all two or three of us and hop on over to her stream. So with that, we'll say good night for today, and we will see hopefully everyone in a week.